In this video, I will continue with two-variable truth tables. If you have not yet watched my Part 1 truth tables video, I recommend watching it after this one. It should help with understanding P or Q and negations. In this video, we will be looking at whether or not this statement given here is a tautology. A tautology is a statement that is always true, so we need to work out this truth table to see if the last column has all truths in it. For the first two columns, we will just write all possible values when dealing with a two-variable truth table. We can either have P is true and Q is true, or P is true and Q is false, or P is false and Q is true, and lastly, P is false and Q is false. Given these values in the first two columns, the biconditional, which is right here in column 3, this is also read P if and only if Q. This is only true whenever both parts are true or both parts are false. So the top line says true if and only if true, which is a true statement. True if and only if false is a false statement. False if and only if true is another false, but false if and only if false is true. For the next column, we just need to negate or do the opposite of the P column. In the first line, P is true, so negation of P is false. Second line is the same, and the third and fourth line, P is false, so negation of P would be true. In order to complete the next column, the negation of P or Q, we need to look at the negation of P column and the Q column. Keep in mind this is an OR statement, which is what this V shape means. False or true. And that's a true because in an OR statement, we just need one of them to be true for the entire statement to be true. Since the negation of P is false and Q is false in the second row, that means the OR statement is false. For line 3, true or true is true, and in line 4, false or true is true. This last column is the most challenging, but keep in mind that overall, this is an if-then statement. An if-then statement is always true unless the beginning part is true and the ending part is false. The beginning part is this column here, the biconditional P if and only if Q, and the ending part is this column here, not P or Q. So the first row says if true, then true, which is a true statement. The second row says if false, then false, which is also true. The third row says if false, then true, which is also true. And the last row says if true, then true, which is also true. So the given statement is definitely a tautology because the last column contains all true values. Let's try another problem. In this problem, we're trying to prove whether the top statement is a tautology. Again, we can complete the P and Q columns. The negation of P is just the opposite of the P column. So when P is true, negation is false. When P is false, negation is true. The negation of Q is the opposite of the Q column. When Q is true, the negation is false. And when it's false, the negation is true. Next, we get to the P and Q column. For P and Q to be true, both P and Q must be true. So only the first line has P and Q true. The other lines have at least one false for P or Q, and therefore they are false. For this next column, we are trying to determine the negation of P or negation of Q. So we're looking at the negation of P and negation of Q columns, and we just need one of them to be true in an OR statement for the entire statement to be true. In the top line, they're both false. In the second line, one of them is false and one is true, so the OR statement is true. In the third line, one of them is true, and in the bottom line, both are true. Next, we'll take a look at the last column. Keep in mind that overall this is an OR statement. So we're just looking at the first part of the statement to see if it's true or false, and the second part of the statement, and then one of them has to be true for the entire statement to be true. So true or false is true, false or true is true, false or true is true, and false or true is true. So once again, we have all trues, so therefore, yes, this is a tautology because the last column is completely true. Let's try one last problem. Let's complete the truth table to determine whether this is a tautology. We can complete P and Q by completing every possibility. Next, when completing if Q then P, we need to think of the Q column being before the P column. So if true then true is true. If false then true is true. If true, then false is false, and if false, then false is also true. The next column is the negation of if Q, then P. So we just look at the column before it and change the truth value. If Q, then P is true, then its negation would be false, and if it's false, it would be true. For the very last column, we need to compare the values for P and the values for the negation column. And keep in mind this is an OR, so we just need one of them to be true for the final column to be true. So the top line says true or false, which is true. Second line is true or false, which is true. False or true, which is true. The last row, however, contains both falses. So false or false, which is false. So the answer to this problem is no, this is not a tautology because we have at least one false in the last column. In my next video, I will be covering 3 variable truth tables, so please subscribe for more math tips.